Hello, this is Mr. Miller. Welcome to video 5C. In this video, we're going to do more examples of finding absolute maxima and minima. If you recall, if a function is continuous on a closed interval, like this one here, so it includes its endpoints, it's guaranteed to have an absolute maximum and minimum somewhere. The places where it can have an absolute maximum and minimum are either at the critical points. So for instance, this point right here in this graph, that's a critical point, or down here, or at the endpoints. And for this particular function, we see the absolute maximum is up here, and this point looks like the lowest of all. That's the absolute minimum. So in general, we check the critical points and the endpoints to see which one's the largest and which one's the smallest. Okay, 4 examples, kind of different examples. So this one's a rational function, and we got to find the critical points. So first we got to find the derivative. So since it's a rational function, we have to use the quotient rule. We got to do g times f prime minus f times g prime over g squared. So we've been here a number of times, so we're familiar with the quotient rule. Y prime would be x squared plus 9 times f prime, which is 9, minus f times g prime, which would be 2x, all over the quantity x squared plus 9 squared. And this is equal to 9x squared plus 81 minus 18x squared over x squared plus 9 squared. And I get 81 minus 9x squared over x squared plus 9 squared. Now, we're finding critical points. So we're interested where the derivative is either undefined or equal to 0. This derivative is defined everywhere, and it'll be 0 when its numerator equals 0. So we get 81 minus 9x squared equals 0. And if I move the 81 to the other side, we get minus 9x squared equals negative 81. Or x squared equals 9, which means x could be plus or minus 3. But we're interested in the interval from 2 to 4. So the critical point negative 3 is outside the interval. So really, the only critical point we have to worry about is x equals 3. So we have to check the endpoints at 2, the critical point at 3, and the other endpoint at 4. So we check the value of the function at these 3 places, and it turns out that this is 1.38 when we put 2 into the original function. This one gives us 1.5. and this one gives us 1.44. They were very close. But we see that this one is the absolute min. It's the smallest, okay? And this one here, the critical point, is the absolute max. Okay, that's our method. All right, let's try this one. This one has a rational exponent. Okay, so sometimes these with rational exponents have a place where the derivative is undefined. So let's see. So y prime would be 2/3, 2x plus 8 to the 1 less power, which would be minus 1/3, times the derivative of the inside function. So we're using the general power rule. And we get y prime is 4/3. If I write this as a radical, it's 1 over cube root of 2x plus 8, which is the same as 4 over 3 times the cube root of 2x plus 8. Now, this fraction is actually never equal to 0 because the numerator can't be 0. But there is a value that makes the denominator 0, and which would make the derivative undefined. And that would be x equals negative 4. When we put negative 4 in the original function, it's okay. It's equal to 0. But when we put it in the derivative, it's undefined. And what we're talking about is this point right here in the graph. It has a cusp, and it doesn't have a derivative there. But that's a critical point. All right, and the absolute minimum looks like it is there. So we got to check the endpoints. F of -5, that endpoint. We got to check the critical point. And we got to check the other endpoint. So the absolute max and min have to occur at these 3 points. One of these 3 points. Alright, so when we evaluate it this time, we get 1.58. You can just use your calculator to find that. F of -4 is 0. And F of 1 is about 4.64. Okay, so this one is the absolute min. And this one is the absolute max. As confirmed in the graph, we see this critical point here is the absolute minimum, and this endpoint is the absolute max. Alright, we're half finished. Here's another one with a rational exponent, but I don't think this one's going to have a critical point. So let's see. We take the derivative. Y prime is 1/2. It will be 6x plus 12 to the 1 less power, so 1/2 minus 1 is -1/2, times the derivative of the inner function, which is 6. 1/2 times 6 is 3. We'll put that in the other thing in the denominator here with a square root. And again, we see that this derivative is never equal to 0. It is undefined at x equals -2, but that's one of our endpoints. That's a point we're going to check already. And actually, you see right here, the derivative would be vertical, which means the slope is undefined right there. So we just got to check 2 points, f of -2 and f of 4. There were no critical points, so just the endpoints. So f of -2 is 0, f of 4 is 6. This is the absolute min, and this is the absolute max. And I love having a graph because it kind of verifies what we found on our own. That's the minimum right there at that endpoint. That's the maximum at that endpoint. All right, we just got one to go. This one's kind of a different flavor. We're going to do a trig function. We want to know the absolute max and minimum of sine of x from -π/2 to 3π/4 over that interval. Okay, start with the derivative to find the critical points. So the derivative of sine is cosine of x. I'm going to set that equal to 0. So we got to find out where cosine 0 on this interval. Well, -π/2 is actually right here. That's the same as 3π/2. That's -π/2, and we're going to go around to 3π/4, which is all the way over here. So we're kind of going around these angles through the unit circle from -π/2, past 0, past π/4, past π/2 to 3π/4. Now, we need to know where if cosine's ever 0 on that interval. Well, cosine 0 at this endpoint, we would consider that anyway. And cosine is 0 again at π/2. Remember, we're looking at the x coordinates. So for these angles, it's really 0 at π/2. Alright, and that's the critical point. So we got to check the endpoints. Actually, what am I doing here? We got to find f of -π/2. That's a 2, believe it or not. And we got to find f of π/2. Alright, the trig is throwing me off a little bit here. And we got to find f of 3π/4. Alright, the first one and last one are the endpoints. π/2 is where the critical point is. So when you put -π/2 into sine, you get 0. When you put π/2 into sine, you get 1. And when you put 3π/4 into sine, right here, you get square root of 2/2, which is about 0.707. All right, this is the winner for the absolute minimum award. And this is the winner for the absolute max. Okay? Again, we can see it at the graph. At -π/2, that endpoint's our minimum. At π/2, that's the critical point. That's our max right here. This endpoint's a little bit lower, so it's not the absolute max. Okay, time for you to do just 2. So this one, you'll need the quotient rule to take the derivative. Remember, you're going to set the numerator equal to 0 to find the critical points. And this is one of those ones where the derivative is undefined at a point. You got to find that point it's undefined. That's your critical point. So remember, check the critical points and the endpoints, and your maximum, absolute max and min are there somewhere. All right, best of luck to you.